Hello. So we move on to our next another question. Okay, this is under the concept of dispersion. It's just a problem solving. Okay, let's look at a question. I've simplified the question. So now the table shows mathematical test results of two teams. So you've got team P and team Q. Okay, so that means each team comprises of 6 members. So we have got 6 different marks. Okay, so team P and TQ. And now question says determine the mean and the standard deviation. You want us to find the mean and the standard deviation of the marks from team P and team Q respectively. All right. Okay, so if we are looking for mean, all right, so what I did was this is for team P. I just wrote it down vertically down. So my x and my x square. Okay, so my total for my x I got as 438. This is x square, means individual marks is actually squared. So 60 squared is 3600, and 65 square and so on. So we add this up. So this is what I got. All right. Okay, so now we're going to look for our mean. So your mean, okay, the formula is over n. So this will be 438 over 6. Okay, so our mean value will be I got about 73. Okay, so the mean mark is 73. Okay, now we go for your standard deviation. Okay, standard deviation is square root of summation of x squared over n minus the mean squared. Okay, so this is what we got here. 32666 over n minus 73 squared. Okay, so let's calculate this. 32666 divided by 6 minus square. Okay, so we square root. I'll get about 10.74, 739, so 74 lah. Okay, alright, so that is for P, for team P. Okay, now for team Q, I'll do the same thing. Okay, so for team Q, alright, so I've done this. This is my x, and this is my x square. Okay, so I'm going to look for my mean. So summation of x over n. So it's actually the same value. So most likely we'll actually get, okay, so you'll actually get 73. It's the same as just now. 438. So the mean is 73. So it's the same as the previous team. Okay, now we calculate the standard deviation. Right. Okay. Okay, so this will be 6 minus 73 square. Okay, let's do the calculation. Square root the answer. Got about 6.73. Okay, so both the teams got the same value. Okay, but the standard deviation is different. So I'll just record this. So the mean, this is for team P. Okay, my mean is 73. The standard deviation that we got is 10.74. And for team Q, the mean is 73. The standard deviation that we got was 6.73. Okay, so now based on these two results, okay, now the teacher would like to select, he wants to select a team to represent the school. Okay, which team would the teacher pick? So you've got two teams, all right? So normally when we look at the average, that's the most likely quantity to look at when you want to actually look or pick something. But here the mean is the same. So the next quantity that is available here is your standard deviation. So for standard deviation, one team, this is team P. Team P got 10.74 and team Q got 6.73. So if you were to select, okay, you will actually select this. Okay, the teacher will actually select team Q. Why? Because when we look at the value of your standard deviation, okay, usually when you have smaller values of standard deviation, okay, what does that mean? That means your data that you have actually collected, okay, it is not very widely scattered. So meaning here, the scores obtained, okay, by these team members from TQ is actually very near to each other, or they're actually very consistent. Okay, that is why the value is actually smaller. So when the value is smaller, when you want to actually pick a team for any competition, the smaller the value, the better it is, because it shows that their results, okay, are actually more consistent compared to a team with a bigger standard deviation. Okay, so in this case, the teacher will pick team Q. The reason being because, okay, the value of the standard deviation, the standard deviation is 6.73, which is smaller compared to team P. Okay, so I repeat again. So 6.73 shows that the scores obtained by members in team Q are actually more consistent. All right, thank you.